Okay, so welcome back. I believe, nearly good afternoon. Still a few minutes to go to the afternoon. So this is still part of our morning session. And I have the very big pleasure of welcoming Professor Rodolfo Haber Guerra from the Centro de Automática y Robótica in Spain. It's a very big pleasure to welcome you over here as our keynote speaker with the presentation titled Towards Industry 5.0, Some Research Challenges and Opportunities. Professor over here is a very well-renowned figure, so I am not going to stay reading out all his very wonderful achievements. I am sure you're all familiar with his work, but it is a great honor to have him here addressing our keynote speech this morning. So please join me to welcome Professor to the stage. Thank you.
Thank you. Okay. Yes, please. Someone told me just a couple of minutes before that I have all to say in 20 minutes. I will do my best because I'm in charge of compensating a little bit the delay. So anyway, thank you very much. Thank you very much, Professor Cantalanza, for the introduction, Professor Francesco Longo and all colleagues. It's challenging to talk about Industry 5.0 when we know that there are many companies, many small and medium enterprises, and also which are still in 2.0. But anyway, this is a challenge. We are researchers. We use also to work with companies. No, I don't have the control. If you pass to me the control of the slides. Yeah? No? Not yet? No. Okay, I guess. Okay, good. Okay, this is the scope of my presentation. I'm not going to enter any details. I have different topics to talk about, from cyber-physical systems. Of course, I have to tell something about AI. And then in the third place, I'm going to talk about Industry 5.0, some barriers, some enabling technologies, and finally, some concluding remarks. Okay. Well, actually, as I already said, my name is Rodolfo Haber. I'm a full research professor from the Center of Automation and Robotics. We are a task force of Politécnica de Madrid and the Spanish Council for Scientific Research, which is the top research institute on this field in Spain. And we are addressing all topics related with the automation and robotics and application to different fields. And specifically, I'm the chair of a research group of GAMHE. GAMHE is the group of advanced automation of machines, highly complex processes and environments. And since almost 30 years ago, we have been addressing the way of combining or the intersection of automation and artificial intelligence driven by AI to address different topics, basically modeling, control, supervision, and optimization. And why? Because as maybe some of you know, that Spain is in the top 10 of machine tool manufacturers in the world, and also has a relevant role in the manufacturing and manufacturing sectors. Why to start with cyber-physical system? Okay, cyber-physical system, we have to come back to 2006, Helen Hill, National Science Foundation. I don't have enough time to provide all details. What we already know now about cyber-physical system is that we are talking not only about large scale and complex system, but also decentralized. Okay, sorry. Thank you. But also decentralized network composition of heterogeneous. I think that the keyword of when we talk about cyber-physical systems is heterogeneity. But what also is rather important is when we talk about cyber-physical system, we talk about emergent behavior and a large scale, not only from the viewpoint of distribution, but also about the richness of subsystems. Okay. Okay, and why? Because cyber-physical systems are indeed the cornerstone of Industrial 4.0. It means that when we talk about cyber-physical system, we are talking about the cornerstone of Industrial 4.0, and when we talk about Industrial 4.0, on the contrary, we are talking about a special field of cyber-physical system application. And nowadays, in this slide, I want to point out the four main aspects related with Industrial 4.0, information, communication, cyber-physical system, as I already said, as the cornerstone, and at the end, the physical automation. Okay, but things have been moving very fast. I'm moving from 2006 to 2020. And then new concepts and new paradigms has already appeared. Now we are talking about cyber-physical social systems or cyber-physical human systems. We're talking about a system in which humans are integrated in the physical system together with communication, computer, and other technologies. And I want to remark in this slide, we have already reported some of this review in a book that we published 5 years ago, edited by the Spanish Council. It's the volume of Artificial Intelligence, Robotics, and Data Science. But also recently, we have the report of the IEEE Control System Society, in which they pointed out two out of many challenges of cyber-physical human systems or cyber-physical social system. One challenge is the characterization of models of humans and their interaction. And we are here plenty of research topics from physiological modeling and so on. And the second one, not the last one, there are many topics, is the human-centered control design. And here we are talking about methods in which as you already know, we are talking about human centricity. Okay. And now it's impossible to come here and not to talk about AI. I don't have enough time. I have only a couple of minutes to talk. These are some top takeaways. Not 10, almost 7. These top 10 are not mine. You can find details of these aspects in 2 books. One is the report of MIT Technology Review from 2024. The second one is the report of HI, the Carnegie Mellon report. This is about 500 pages. In summary, you have here some top takeaways. Indeed, nowadays, everybody knows that AI can beat human on some tasks, but not all yet. And then we know that the United States is still leading large language models. We can say this 1 year ago. Now it's not clear at all. But here in blue, in almost the last of the slide, is that AI makes worker more productive. This is undoubtedly and leads to higher quality work. And then let's see how AI can help us. Okay, this slide, this figure is from this report of Mid Press. This slide has been updated. Nowadays, I just want to send one message. Multimodal AI. I would recommend to check all AI large language models that we have. Here I have pointed out some from the best of my knowledge, which are just in the frontier. The first one is Sonnet, is the last one for Anthropic. And the others are GPT-5, already everybody knows about OpenAI, but there are also very good large language models provided by Chinese companies. This is the situation of Qwen. If you don't know them, I recommend you to check. And here, once again, from this slide, is the key message is that data is essential for AI, but at the same time, we can create with AI new data. And we will see at the end of the presentation one example. And from people who are interested in robotics, I would like to point out that robotics is also in the core of AI. We know that what NVIDIA is doing now, in short terms, they will launch the short language model just for robotics. If you are interested in robotics, I recommend Palm E and R2, which are free. You can use it, and you will see how visual language model can be explored in robotics, but also in human machine cooperation. Okay, we arrive. Yes. But when we talk about Industry 5.0, it's difficult to find a definition because, as far as you know, I know many companies in Spain, also in Italy, in Greece, even in Germany, in many countries, that they are still in 2.0. So they are starting just installing new communication systems. At the end, we are talking about transforming raw materials into higher manufacturing goods. This definition is from the European Commission. These are the 4 pillars of Industry 5.0. One pillar is efficiency, of course. Efficiency will be always there. And there are other 3 which are relatively new. One is human centricity. Another one is sustainability. And the last but not least is resilient and reliable. And not going to address all of these topics. I will concentrate in this presentation on human centricity. Why? Because sustainability more or less is being addressed in many works previously, and resilience is also a topic which have a big community working on that. And here you can see some aspects around AI. AI means more accurate, efficient, and sophisticated decision making. Okay, which are the key issues? Okay. In this slide, the key question is how are we able to promote this cooperation and interaction between human and machines? At the end, when we talk about Industry 5.0, we have something which is relatively new. It's the human. We are coming back to early of 2020 when humans were in the loop, but let's say in another stage. At the end, we're talking about liberating human from physical and intellectual labor via AI. This is a little bit tricky sentence, but at the end, what we are trying is to support humans in their activity. And in this figure, you can see the main difference between Industry 4.0 and Industry 5.0. When we talk about information, now we have to talk about intelligence. When we talk about communication, we talk about connectivity. When we talk about cyber-physical system, now in Industrial 5.0, we talk about cyber-physical social system or cyber-physical human systems. Okay. Okay, industrial needs. Okay, this slide is almost the same. We have to check. When we talk about human centricity, where are humans? Where are humans in this slide? We are showing the pyramid of human needs. And when we talk about Industry 5.0, we can say that the human factors in Industry 5.0 could be around level 3 and level 2, but there are many things to be done already to achieve the level 5, the self-actualization, self-fulfillment, leadership, personal growth, and so on. Okay, barriers. Okay, I know that many here, this audience are mainly from academia. I know there are some companies. Talking about Industry 5.0 is risky. It's risky from the viewpoint of research, basically because we don't have nowadays a discipline that in which is included the humans aspects into the physical systems. There are also a lot of foundational knowledge gaps. For instance, human digital twins are being developed. I know many colleagues working on human digital twins, but there are many things to be done in the academia to find the foundation, to develop the foundational aspects of Industry 5.0. But at the same time, we have technical barriers. Here, you may find some ones related with the legacy system integration, cybersecurity, data interoperability, and so on. But in the top of all of this, there are companies. We need companies. Many of us are students, PhD students, professors, researchers. We need companies to pay taxes to support the public sector. And here you know that there is a big crisis related with the need of reskilling, the reskilling crisis. We're talking about more than 40 billion of euro to reskill workers. We are talking about that SMEs should face about 40,000 euros per worker replacement cost. So there are a lot of barriers. There are a lot of economic barriers that should be overcome in the coming years. And of course, the size matters. The size matters because it's not the same when we talk about one small company than when we talk about large companies. Different problems, different challenge. When we talk about SMEs in Spain, we have most are SMEs, manufacturing SMEs. Many of them, they are even not aware about funding programs of the government at this moment. This is one example, but there are many. They are lacking support. And this is the role of many researchers and universities trying to help, to aid companies to overcome these gaps. And now the situation will become worse and worse and worse. I want to be optimistic, but the situation is that our employees in the companies and in general, the society is not ready for what is coming. What is coming is that by 2033, there will be about more than 2 million of employees that cannot be covered by companies. We have talking about economic loss of near 1 trillion of euros. We are talking about 90% of companies are going to face problems related with anticipated skill shortage and the need of workers need training. We are more than 50% of all companies personnel will need upskilling. Okay, and what we can do? Okay, we can do many things. We can do things in this slide. There are things that we can do at individual or micro level, things that we can do at organizational meso level, are things that we can do at economic level, and economical societal level. I'm not going to enter in details. I'm going to pass to the next slide. When we talk about physical, about the human factors, when we talk about human centricity, we have one important aspect of human centricity is the human factors. We have the physical facet, the cognitive facet, and the physiological facet. And indeed, we are engineers, we are physicians, we need to measure. And when we talk about human factors and physical facets, we know how we need to measure these physical facets, how we measure these physiological facets, and how we are able to measure this cognitive facet. Of course, this is not straightforward. Measuring is not straightforward. We have, in this slide, I just pointed out some aspects. At the end, we need to measure, to estimate these human factors. We have sensors, we have devices, but even now, everybody's aware about glasses, watches, and so on. Many of these devices are very intrusive, cannot be applied in industrial environment. And these are the main bottleneck that we have still. But this bottleneck will disappear because there are new devices that are being developed. Okay, I'm almost running, Francesco. I'm trying to. Okay. Talking about enabling technologies, just before coming, I have been checking the program. And it's quite impressive to see all these very interesting papers addressing from AI to a lot of technologies. In this slide, I'm just mentioning some relevant technologies, some relevant enabling technologies, not all, but some. And these 8 technologies somehow are cross-correlated. So if you are addressing one problem, you will need at least 2 of these technologies, because Industry 5.0 is challenging. It's challenging, once again, not only about physical subsystems, about complexity. It's also challenging because the human behavior is there. And we talk about big data, edge computing. And I'm not talking here about AI. I'm talking about engineering AI. Why? Because one thing is engineering AI, another thing is making AI methods and engineering methods. Some challenge. Okay, now I have a couple of slides to talk about challenge. The first one, as I've already pointed out, is new jobs. Everybody's concerned. I read there is one or two papers about the risk and the danger of AI for employments and so on. I couldn't read the papers. I only read the title of some papers. There are some, we are confident that there will be new jobs in short terms. These are some examples of managers or managers of digital workers, something which is, you cannot imagine this only a couple of years ago. But of course, there are challenges related with technical issues. There are here in this slide, there are three aspects. One is the mass personalization. The second one is heterogeneous data transmission. And the third one is enhanced efficiency and productivity. And in each one, there are several aspects that we should address in short terms. One of them is related with the large language models and generative AI, of course. I'm not going to talk about data security and privacy, but this is important aspect to be considered on AI. This is also concerned with ethical aspects on AI and Industry 5.0 that I'm not going to address in my talk, these aspects. And last but not least is, once again, data interoperability. We are talking about, there are many legacy systems already deployed, and the challenge is how are we able to develop new methods compatible with this one? Are sweet dreams made of this? This is a song from the 90s. Yes. Okay, when I'm not a philosopher, but I'm very interested in finding the roots of things. When we talk about Industry 5.0, there is one Austrian philosopher, Karl Popper, that almost, let's say 40 years ago, he developed the three worlds theory of reality. Do not confuse with the Chinese theory of three worlds. It's another thing. So, and at the end, we consider that this is indeed the actual philosophical roots of Industry 5.0. We have the physical world, we have the mental world, and we have the artificial world. And the interaction of these three worlds is what we are, we have to address, developing new methods, new technologies in the coming years. But what is important, my message is that what we are doing is creating the basement, only the basement of a better world for the next generation. And this is what we on the shadow. So, but come on, we have to be realistic. And recent studies are telling us that when AI and robotics are with humans, things are not what appears to be. We're talking about social laughing. We are talking about boring, people that become boring. When you have a robot working with you, you are bored. And this is something that recent studies are being showing, and there are many companies concerning about what will happen when AI and robots will be with human in our factories. Here you have the reference of this word from the last year, just to motivate you to think about it, about the social laughing. And where we are going? Well, okay, in a few words, we are going to, let's say, knowledge factories for knowledge workers with knowledge automation. What is from my point of view, the challenge is, are we be able to put digital workers, human workers, and robotics workers interacting together in a reliable, safe way, and so on? This is the challenge. How elements for physical, social, and cyber spaces can interact with digital workers. Cornerstones. Here we have some cornerstones. I have 5 minutes. Okay. When we talk about cornerstones, once again, we have to think about a new generation of operating systems. We need to think about to develop human-oriented operating systems. We have to develop the new generation of workers, not only human workers. We have to develop digital workers. We have to develop robotic workers. And what will be their role in the factory of the future, in the industry of the future? Which type of operating models or working models we will have? This is other issues that we have to think about it. Okay, what we are doing, this is interesting. Okay, we are doing several things. We are about 25 people in my lab working in different projects. These are some samples of projects. I'm going to pass very fast into I'm not going to enter in detail. I'm just to mention what we are doing. We have been involved in community of practice of Industria 5.0. This is an initiative of the European Commission. The European Commission have been working in the last 1 year in two main ways, two main paths. One is related with the development of Industria 5.0 prototype of learning and assessment tools. And the second one is to creating an inventory of Industria 5.0 pilot projects. And this is what we have done. We have a pilot line for Industria 5.0 in which we have human and machines interacting together. Okay, we'll skip it because we don't have enough time. There will be in the video is available in our YouTube channel. You can have a look later. Now in relation with the projects we are running, we have been engaged into topics. One is related with self-reconfiguration driven by interaction of among operators and production systems. We started this work almost 3 years ago with Politecnico de Milano. The idea is, at the beginning, was to develop a self-reconfiguration without humans, and now we are including a human-centric approach, how we are developing new methods to embed the operator's behavior and profile into self-reconfiguration and self-adaptation of machines at different levels, at software and at physical level. And we are also doing new methods for basing off using standard reality to improve junior worker skills. This is basically for training. There are, as far as you know, there are a lot of difficulties in training new junior workers and so on. And here this is another video in which we have one video in which we are doing this training using extended reality, using the HoloLens glasses for improving the capacitation, the training of workers. And this architecture is relatively complex because we have the cloud, we are running some algorithm in the edge and others in the clouds. But the idea is to improve the training experience of junior operators. Okay, I'm almost finishing, because I know that I'm under pressure. These are some final remarks. I'm so sorry for running because Francesco, they will cut my neck. These are some remarks. In relation with the remarks, these are some remarks. It's impossible in 25 minutes to summarize what we are doing and what the community, what the scientific community is doing related with Industria 5.0. Okay, we need to consider, of course, robotic systems is there. We cannot talk about Industria 5.0 without robotic systems. We have to think about holistic approaches from use cases, from problems in the industry, coming back to research questions, enabling technologies, new training skills and use cases. And my final message is that AI is not ready yet for engineering. We have to re-engineer AI. We have to redesign, re-elaborate, recondition, and so on, if we are really interested in developing new methods for context-aware adaptation in dynamic manufacturing. For finishing, I have this. I hope that you will also enjoy.
Thank you very much.
Yes, please. Yes, of course. I think it's, yes, the microphone. Yes, I'm sorry, I forgot questions. I was listening to the sun. Okay, the sun is
I'm
completely.
very happy to see that either me and you or me and AI share very similar musical notes.
When you select one style of music is something that is. But anyway, this is completely done using AI. So there is nothing from my side as human. So the lyrics, the music, the video, everything has been done with AI. This singer does not exist. But let me tell you that I'm the owner of the copyright of this song because I created, I did the prompt to do it. But anyway, this is just a joke. It's about Industry 5.0. So yes, please, question.
So, any questions from the
Yes.
floor, please?
Yes, please.
We're bringing a mic. Just a second. Thank you.
Excellent presentation. Loved it. One question. When we talk about human involvement in Industry 5.0, you mentioned something about complexity. What's your take on that? Like, which perspective you're mentioning on the level of complexity there?
Okay, complexity means that we have already in the engineering system theory methods that we have already applied, and in the last 50 years, we have developed a lot of methods. What we have to do is try to elaborate these methods from non-linear and linear system theory and try to adapt, to elaborate and to apply, because these are tools that we have already in our backpack. The idea is that there are many people working on AI, but many people working on AI, they are not aware about that. More than 100 years ago, there were people developing theorems and foundation for engineering, for system engineering. And I do think that it's necessary to extend method, to create new methods to deal with this complexity.
Thank you.
Okay. Any other questions, please?
Hello, Luc Olibert. I'm working for Goodyear. We are in the industry. And
how is your large language model? It's progressing.
We are using Copilot. We are not allowed to use ChatGPT or other LLM model for cybersecurity reason. So I thought we didn't add a clear definition of Industry 5.0. I thought we stop at Industry 4.0. And 5.0 is a bit of, I think, industry point of view. It's not a value judgment. It's a bit wishful thinking to think having the human in the middle of the automation. When we are automatizing an operation, we want to remove the humans, not collaborate. Collaboration, machine and human, is a safety risk. We want to avoid a safety risk. And we want to get full benefit of automation. If we still have a human in between, we will have half of the benefit of automation. And I think the vision of Industry 5.0 by the academic world is a bit idealistic. And I'm afraid the harsh reality, the goal of the business is to make money. And the true Industry 5.0 might be the replacement of the human by humanoid robot or other automatic machines. But we still need people with imaginations because AI is lacking imagination. So we want to remove risk, remove physical pain, improve consistency, improve quality, improve profitability. Why? I'm presenting Friday if you want to see. But we have a cost challenge in Europe. And we need to be competitive again. And there is a possibility with AI to become or be competitive again. And that is not by mixing robot and human, I'm afraid.
Okay, interesting. Indeed, this is the viewpoint of large company. But unfortunately, in Europe, we have, I don't know, at this moment, the last study reported about 100,000 SMEs related with just direct or indirectly with the manufacturing sector. It means that there are people now, and there will be people working these SMEs and the challenge from the industrial viewpoint. We are running some projects in Spain with some companies like Haber and other big players. The key point is that we have to convince companies how they can monetize. How can they estimate efficient ROI, return of investment? But if the message to SME, the message to the companies that using this method, you are going to reduce the absenteeism. You are going to reduce, in Spain, for instance, we have more every week, 10% of operators don't go to their factories and their companies. If you reduce the absenteeism, if you reduce the burning out of many employees and so on, you can monetize this. This will be, at the end, there will be money on the shadow. And this is the challenge, to translate this, let's say, this beautiful topic, because when we talk about human centricity and resilience and sustainability, what we are thinking about is a better world for the new generations. How we can translate to make this compatible with the companies. In the case of large companies, topic is more complex, but even large companies have to keep employees. And the concept of Industry 5.0 is not, in this paradigm, is not a European paradigm, it's a Japanese paradigm. Just 20 years ago, Japanese started to talking about Industrial and Society 5.0. They have some big pilot lines in Japan, in some cities in which factories interact with cities, people in the cities, and with the whole ecosystem. I think that we have to help companies to find to identify these KPIs that enable companies to trust. Because even we know that there are companies that they are not trusting on Industry 4.0. So it happens, but this is a challenge for the COVID years. And thank you very much for the question.
So thank you very much. Thank you, Professor Haber. And obviously, you have the opportunity to continue our discussions with Professor Haber in the coming days. So thank you once again. So please allow me to thank you. Thank you very much. Thank you. Yes, thank you. Thank you. Thank you. Thank you.